family of enveloped single-stranded RNA viruses that include rubella.
Irritation and skin rash on our hands and feet and wrist, ankles.
I'm gonna go muscle test it. Venom-producing snake organoids developed in the lab. This is the thing that I think is surprising to me about the snow. Because how is a virus surviving on a medium that isn't living? You know what I mean? Like, it's not, snow doesn't have the same properties as like agar, you know, in a petri dish, or a living person, you know? So like how is this in the snow? If not somehow engineered to be there? If you guys don't know, my name's Elizabeth Clark. I'm a former diagnostics research and development laboratory director, former clinical dietitian, and 7 times published biomedical researcher. I also helped co-develop the world's first advanced self and proxy muscle testing methodology discernment framework, along with my colleague, Kayleen Tinker, who is out on maternity leave because we muscle tested too hard and cured her unexplained infertility. So yay to Kayleen and baby Coco. When we study muscle testing as a screening tool under the broader umbrella of study design as it pertains to diagnostic tools, validation studies is what we're talking about, and you would compare it to a gold standard in the diagnosis or the screening of whatever it is you're diagnosing or screening. So this could look like comparing it to PCR, comparing it to mass spec, comparing it to IgG food testing, you know, that sort of thing. So you have to get more granular at what it is you're actually testing with muscle testing before you can actually create the study design and determine whether or not it's accurate. So in this case, you know, we tested things that you could test through culture, test through PCR, or test through mass spec. And what we would do to validate this, you know, whether or not this is accurate, is we could send this to a lab. It would go through potentially all of the above, you know, and they would maybe need 100 different samples of the snow compared to just regular distilled water, you know, ice potentially, or just regular distilled water. I don't think it needs to be frozen because you'd have to melt it anyway to prepare this sample. So yeah, they would compare this highly contaminated and adulterated sample of snow. We'd probably gather 100 of them from different places in the same, you know, yard, or they could just take 100 samples from this one larger sample from this one place, and then they would compare it to 100 different samples of distilled water, and they would run it through these various diagnostics to see if they found any viruses, bacteria, or toxicants. I don't think we tested any toxins. I wish I had that in the test kit because I would love to know about venom. If you know, you know. I'd love to know about snake venom. Maybe I should. BRB. So let's do venom. Should I reset? Yep. Okay. Okay, so let's go ahead and get our reference sway. We're isolating the snow instead of holding it in our hands. All right, now we're looking at microscopy of venom-producing snake organoids developed in the lab. Well, I mean, that's a little surprising, right? Should we, okay, I don't know if you guys heard this conspiracy theory. Marburg virus under microscope. I'm getting in the weeds. I should not even be. Okay, let's get a reference way. All right, now we're going to look at the microscopy. No, okay, cool. It's not that. Should we look at specific venoms? No, okay, because there's just too many. But, you know, I think that's enough for today. I do maybe want to see if we can narrow it down to one of these, because this is a category of viruses, and these are two different viruses in this category. I'm going to grab this because these things communicate. So we're going to isolate the snow. When you're muscle testing, oh my God, I'm so hot. When you're muscle testing by just looking at a data point, you want to do it so that the data point is like straight ahead, so that there's not eye movements involved in the testing, because eye movements themselves are a data point. So you're not getting a very clean test. So what I'm going to do is I think I'm just going to like maybe not necessarily look, because there's no way to get this dead on in my line of sight without just having my back to y'all. And I want you to see this way. So I think what I'm going to do is, instead of looking, touch, sort of point to that data point. Okay, so isolating the snow, get a backwards sway. Not a correlation. Not a correlation. Okay, but there is a correlation, just not with either of these things. So there's a different toga virus that Google didn't pull up. Okay, now what I want to know is if these two things are related. So let's get into stacking data points in our correlation. Reference sway is backwards. That reversed it. Now I'm going to look at snake venom, and it reversed it again. That means they're all related. I'm using this like it's a microphone. That means they're all related. Okay, so just to recap, these two things are correlated, and they're the only things found in the snow that I have a hard time wrapping my head around why they would be found in the snow. Why would these things be in the snow?